Hello and welcome to Unit 2, Variables and Expressions. This is Ms. Zampano's flipped classroom for Algebra 1A. We are working on the section title of 2.1, Combining Like Terms. This is our first note sheet for the new unit. And please make sure that you get a chance to add in your name and date. The pizzazz pages that will go along with this would be 6, 22, and 23. We're going to start out with some vocabulary for the new unit, including term, variable, and expression. And of course, combining like terms, since that's the essential title of this section. Let's go ahead and look at a term. So a term is a simple expression with only multiplication. And when I take a look at a term, when I talk about a simple expression with only multiplication, that could be something that's as simple as 4W. So in between the 4 and the W, there is an unspoken multiplication sign right in between them. So I'm going to try and make a dot here. And now let's go ahead and take a look at variable, and a variable is a letter that represents an unknown number. So a variable could be, like used in this example above, it could be W. It could also be an X, a Y. You could use the letter of your first name. So in my case it would be an M. All of those things would work. So any type of letter can represent a variable. I highly suggest not using O because it looks a whole lot like 0. Now let's take a look at the expression, which is patterns with numbers, variables, and operations. So again, operations are the pieces like addition, subtraction, multiplication, and division. You can also have squaring and square rooting with operations, but we're going to work with just the basics for now. And combining like terms, the point of this assignment is when we add terms with the same variable parts. So what do we mean by variable parts? Well, when we talk about variable parts, we're talking about the same letter and the same exponent. So if I have x, I have x in my other term. So in this case, we'll have an example of 3x and negative 4x. Those are two terms in which have the same letter and exponent because they're essentially x to the power of 1. Now let's take a look at another example where we have 5x squared y and negative 2x squared y and positive 14x squared y. So in each of these three terms, we have x squared y as the variable, and in each case we have x squared, so there is an exponent to the x term, and it's multiplied also by y. Similarly, another example, we could use 8c to the third power, 11c to the third power, and negative 45c to the third power. In this case, when we take a look at all three of these, we have c to the third power. In our very first example, like I had said, we had x to the power of 1, which we just write as x. Now we're going to go ahead and look at some key concepts with combining like terms and the steps in order to organize this process. So the first step involved is to identify the terms that have the same variable part. And again, when we mean same variable part, we're looking all the way up here underneath the same letter and exponents. The next step would be to box in like terms, including the sign in front. So we're boxing in like terms, including the sign in front of the term. Please don't forget the sign. You'll notice in our examples why that's so important. And number 3 would be to simplify by adding the like terms together. So first step again is to identify the terms that have the same variable parts. The second is to box the like terms in, including the sign in front, and the third is to simplify by adding the like terms together. Adding is the same thing as combining, so that's why it's combining like terms. And our fourth step is to write any non-like terms after the expression. So if I take a look at these, I have different ways of organizing. When we take a look at some expressions, if we have expressions that have more than one type of variable or more than one type of variable part, then we're going to want to organize our final step in a different way, and I'll describe that on the back side. So see the back to help us organize what happens when we have multiple terms that are like terms. All right, let's go ahead and take a look at some of the examples to start with. So the very first example we have is 16x minus 3x minus adding negative 11x. So I'm going to back up even before I boxed these in. So let's back up a moment. And I noticed that for my first step, all three of these terms have an x. So they have the same variable part because they don't have different exponents either. So we can box in all three of these like we had before. And go ahead and then combine them together. I usually go from left to right to help myself. So 16x minus 3x is going to give me 13x. And I'm going to add the negative 11x to get my answer of a positive 2x. Now I'm going to go ahead and take a look at example number 2, which is negative 67x minus 31 plus 14x plus negative 24. Now in this case, my first step is to identify the terms that have the same variable parts. That's going to be the x's I'm noticing, so I'm going to box those in. And I'm going to box in the negative 67x and the plus 14x. Notice I picked the plus to go with that 14x, helping myself remember it's a positive number. And when I take a look at this, I am also noticing that I have two other terms that don't have variable parts to them. So a negative 31 and a plus negative 24. So I'm going to circle those as a different form of a like term. I'm going to start with my variable terms and combine those. So negative 67x plus 14x. I'm going to end up with a negative 53x. Now, I also have to combine the negative 31 and the negative 24. So doing so, I'm going to get negative 55. And in this case, I always want to double check to make sure that those are not like terms when I have finished off. So if I have a look here, I have negative 53x, and here I have negative 55. This term here does not have an x term, so I cannot combine it with the term in front. So that is essentially my answer. So I'm going to go ahead and box my answer in. Moving on to example number 3 now, I have 1/2 h minus 3 plus 1/2 h plus negative 1 plus 6h. Now in this case, I am going to box in the h terms. So that gives me 1/2 h, the plus 1/2 h again, and the plus 6h. Now you might notice that I don't have a sign in front of this front term right here, but if I don't have a sign, it is assumed to be a positive number. So if I take 1/2 and 1/2 and the 6, I will eventually add those together. Before I go there, I want to make sure that I also recognize I have two other terms that I can put together, the negative 3 and the negative 1. Okay, let's go ahead and take our variable parts and start with those three terms. So these three terms are going to be added together. So I get 1h, because a half plus a half makes a whole, plus 6h. That'll end up with 7h. And then I'm going to go ahead and take the negative 3 and the -1 and put those together and get a -4. Now, one of these terms here has an h and the other term does not, so I cannot combine them. That tells me that I am completed with the work that I need to do, and I can box in my answer. Okay, so let's take a look at the back side. We're now going to flip over and take a couple more notes with some vocabulary. So in this, I would like you to add your section title. This is 2.1, Combining Like Terms. Same thing as CLT. And our vocabulary word I'd like to add on the back here is coefficient. So the coefficient is the number part of the expression, and this really is the part that we're adding together when we're combining like terms. So again, this is the number part that is being multiplied to the variable. And it's actually what we're combining or adding together. So let's take a look. If I have 3x, and let's hold off and go back a little bit. That went very quickly. So if I have 3x, then the 3, in fact, is the piece that I have for my coefficient. The 3 is the coefficient and the x is the variable. So my next piece I'm going to look at is a -14y. And the -14 is the coefficient and the y is my variable. And the final example we'll look at for coefficient is -1/2 w squared. And in this case, the -1/2 is my coefficient and the w squared is my variable part. All right, let's take a look now at some key concepts. I told you on the back we'd take a look what happens when we have different variable parts to a longer, more complex type of an equation. So we're now into our key concepts on the back side. The first step is to combine like terms using the steps on reverse side. So make sure you're still using those steps of boxing in and simplifying. But the addition when we have a more complex equation is that we want to organize terms once they're simplified. So at the time when I can no longer simplify terms, I do want to write my expression in alphabetical order and in descending exponent order. That means, so descending, for those of us who need a little refresher, it's the same thing as going from highest to lowest. I'm going to write that up in here just to give myself a little hint. So descending order, again, means to go from the highest order to the lowest order for that exponent. And we're going to take a look at an example that looks like that so we have an understanding of what that really is talking about. So let's take a look at our first example that is a little bit more complex. So example number 4 says -4a squared plus 2a minus 10a minus 16a squared. Now the variable parts we're looking at here are both a and a squared. So we do have multiple variable parts that have different pieces of like terms that we can put together. So let's go ahead and identify the two terms that have a squared and box those in as -4a squared and -16a squared. And similarly, how about those pieces that have just a? So we have a 2a and a -10a. So I'm going to back that up just a hair and go ahead and stop where we're at. And let's start with identifying our a squared because that is our highest variable exponent. So we're going to take -4a squared and -16a squared and put those together to get -20a squared. Then we're going to do the same thing with the 2a and the -10a. and find out that we get a negative 8a. And we'll add those two pieces together with just a plus sign. We actually cannot put these together because they don't have the same variable parts. This right here is an a squared term, and this is an a term. They don't have the same exponent, so we cannot add them together. This now is my answer. I always want to double check with two questions. Is this in alphabetical order? And the other question is the exponent in highest to lowest form? Always start with that first question because that'll get you in the right process, and then within that you're going to go from highest to lowest order. And taking a look, then I did check those out, and let's take a look at example number 5. This is going to be 9 minus 3x minus negative 8y plus 9x minus y. And when I take a look at this, I have terms that don't have a variable, I have terms that have an x, and I have terms that have y for the variable. Now I'm going to go ahead and do a different piece to help organize that in my brain. So I'm going to box in the x terms to start with, and I'm going to box in the sign in front, so negative 3x and positive 9x. And then I'm going to circle the y terms, so I'm going to circle the minus negative 8y and the minus y. Notice I took the sign in front of that negative opposite, so subtracting the 8y. And I also have this 9 that's hanging out front. Whoops. So again, that went a little fast, so we can back up here just a hair. I'm going to drop the 9 down just to help myself organize. I don't have to combine it with any other term, so I'm just going to drop it down to start with, and then I can reorganize. The next thing I want to do is to combine my x terms, because that to me makes the most sense, and it is in an alphabetical order. I want to go x and then y. So if I take negative 3x and add 9x, I will get a positive 6x. And then let's go ahead and take a look at the negative, or the opposite of negative 8y, and the negative y. When I take a look at the opposite of negative 8y, that's really telling me it's a positive. So if I have 8y minus y, I end up with a 7y, and it's a positive 7y. Now we're going to go ahead and check our answer against these two questions I asked you before. So is it in alphabetical order, and is the exponent in highest to lowest order? My first thing I want to look at is, hey, I don't think that's the case. I do have the x and then the y, but I have the 9 that doesn't have a variable in the very front. And that's not where I want it. I want it at the very back, because it doesn't have a variable. It's not alphabetical then. So I do find, though, that the second question, the exponent is in the highest to lowest order because I don't have any exponents higher than 1. So going ahead to do this, I'm going to put my 6x first, and then the 7y, and then the 9 at the end. The 9 at the end is what we would consider a constant. Again, a constant is something that does not have a variable. So it's a number that doesn't have a variable. And please make sure that you note that at some point. You can absolutely put that up in the top where the vocab is, or you can just note it down here. On the front side, we did have a couple of situations when we did have constants also in the mix. So example 2 also had constants, along with example 3. Let's take a look at the 2 try-on-your-own problems that you'll be working with on tonight. So the first is 13x to the 4th power plus 13x squared minus 2x to the 3rd power minus 4x to the fourth power. So again, your first step is to go through and identify your like terms, box those in, combine them, and then go ahead and order from alphabetical order, and then the exponent should be from the highest to the lowest. Our second example for the try on your own is 7 plus u minus 9x plus 5u. Again, it's 7 plus u minus 9x plus u. Go ahead and try these two problems on your own. Again, the attempt is what you're getting credit for. Please make sure that you have enough time to at least take a good attempt, and we'll go over these in class. So see you tomorrow in the classroom. Thanks for your time.